In lesson 7, we learned a new type of expression that we can factor called the sum and difference of perfect cubes. Just like we factored the difference of perfect squares, there's a same little idea that we can apply and extend to the sum and difference of perfect cubes. It works for both the sum and difference, which is nice. So in class, we developed this kind of rule that if you had a cubed, I don't need parentheses yet, I had a cubed plus b cubed. Well, there's always a linear factor. There's always a linear factor of a plus b. Whatever I cubed plus whatever I cubed. That's the linear factor. Then we have a quadratic factor, and this is where you kind of have to just memorize what goes in this quadratic factor. It's the first piece squared, the opposite sign. So I had a plus, now it's minus. Multiply them together, ab, plus the second thing squared. So you square the first, multiply them together and change the sign, you square the last. And if I had a cubed minus b cubed, so the difference of perfect cubes, my linear factor is still a minus b, times what goes in here. We'll square the first, change the sign, and multiply them together, plus the last thing squared. So it's just a formula and an idea that you need to practice and get good with using, and it flows naturally. Just like you know a plus b, a minus b for the difference of perfect squares, this just is a little bit more complicated with that quadratic term there. So factor the expressions completely. So I have x cubed plus 8. Well, why is this the sum of perfect cubes? Because 2 cubed is 8. So what's my linear factor here? My linear factor, well, what gives me x cubed? X plus 2, because 2 cubed gives me 8. Now I've got that quadratic factor that I have to think about. Square the first, opposite sign. X times 2 is 2x, and square the last is plus 4. That is it. I want to say 99% of the time this quadratic will not be factorable. What multiplies to 4 and adds to negative 2? Nothing. So currently we can't factor that quadratic, which is nice because we are done right now. 1 minus x cubed. So this is the difference of perfect cubes, because 1 cubed is 1, and x cubed is x cubed. So my linear term, that's the hardest part. Once you get that linear term, you just have to know what the quadratic term is. Well, what cubed gives me 1? 1 minus x. 1 minus x is the linear term. Don't change the order around. 1 is in the front seat, so he gets to stay in the front seat. Square the first. 1 squared is 1. Opposite sign, and multiply them together. So that's x, 1x, so x. And square the last, plus x squared. Done. That's all we have to do to factor them, is know that pattern and actually apply it. All right, I have 792x to the 6th plus 64y to the 6th. Oh boy, let's see what we've got here. What number, well, this looks like perfect cubes, but I need to know what cubed gives me 796. What's 6 times 6 times 6? That's 216, that's too small. 9 times 9 times 9. What's 81 times 9? Ah, there it is. So 792, I just played around on my calculator there, is 9 cubed. That's x squared cubed. 64, is that a perfect cube? Yes, that's 4 cubed, and that's y squared. Okay, so once I get that linear term, I should be in good shape. So what gave me 792x to the 6th? Well, that was 9x squared, was in that front seat, plus 4y squared. That gave me, if I cubed each of those terms, I would get the terms that you see above. Now I've got that nasty quadratic term that I have to be careful about. I square the first. Well, how do I square the first? 9 times 9 is 81. X squared squared, because I square both of them, is x to the 4th. Opposite sign. Now I multiply those two together. 9 times 4, x squared y squared, plus square the last. Well, what's 4 squared? 16 y to the 4th. That's how you factor that expression there. It's tricky because you have to keep track of what you're squaring, what cubed, but that finding out that linear term is ground zero for doing these perfect cube problems. We got x cubed minus x. Well, wait a minute, is this the difference of perfect cubes? I'm being sneaky here. It's not, because what do we always look for whenever we factor? GCFs. Is there a GCF I can take out? Yes, there is. I can take out an x, and I'm left with x squared minus 1. Wait a minute, x squared minus 1, that's the difference of perfect squares, x plus 1, x minus 1. That's how that expression factors completely. You have to still remember how to GCF and difference of perfect squares. Everything's not always going to be perfect cubes from this point on. We can only apply perfect cubes if they were both perfect cubes. He is a perfect cube in this first seat. X is not a perfect cube. I mean, I guess you could use the cube root of x, but we're not going to do that. We're just going to take out that GCF and factor it that way. 125z cubed plus 1. Okay, this looks like perfect cubes. Why? Well, 5 cubed gives me 125, and z cubed gives me z cubed. And 1 is also a perfect cube, so we're good to go. So who's my linear term? What gave me 125z cubed? Well, 5z did, plus 1, because 1 cubed is 1, times square the first. Okay, how do I square 5z? 25z squared. Opposite sign, multiply them together, square the last. 1 squared is 1. Done. That's how we do the sum and difference of perfect cubes. It's just knowing that general idea and that general formula. A to the 4th minus b to the 4th. Well, wait a minute. These aren't perfect cubes. This is the difference of perfect squares again. A squared minus b squared, a squared plus b squared. Well, wait a minute again. That's the difference of perfect squares. A plus b, a minus b. I cannot factor the sum of perfect squares. I can only factor the sum of perfect cubes currently. So we're going to leave that a squared plus b squared alone. Don't forget, everything is not magically perfect cubes. Things are still the difference of perfect squares. So practice with that formula. If you need more practice problems, come let me know. But you need to get comfortable with saying, all right, that's my linear term. How do I get the quadratic factor? Well, square the first, change the sign and multiply them together, square the last. It's just a pattern you need to recognize. Hope you had fun with the perfect cubes, because tomorrow we move on to a new factoring strategy.